When we think of human outposts in space, we usually picture something like this: a sprawling, multinational megastructure that demanded decades of assembly and billions of dollars to keep afloat. But look ahead to the year 2030, and a completely new, independently built outpost is scheduled to enter into low Earth orbit. India's space agency, ISRO, isn't trying to build the next International Space Station. Instead of a massive, sprawling complex, they are designing a highly focused, compact habitat. This new station will sit at an altitude of about 400 kilometers. It is designed to keep a small crew of 2 to 4 astronauts alive and operational for precise 20-day missions. Right now, the traditional space superpowers are looking far past Earth orbit and pointing their budgets back toward the moon. India, however, is deliberately anchoring its immediate human spaceflight efforts closer to home. The challenge here is the clock. Constructing an independent orbital habitat from scratch in just a few years requires a rigid, step-by-step technological roadmap to get right. The primary engineering constraint of any space habitat is gravity. You simply can't launch an entire space station on a single rocket. It's too heavy. It has to be broken down into individual pieces. When fully assembled, the station will weigh roughly 20 tons. It relies on 2 primary blocks. The core module acts as the central hub, providing structural connection points. Attached is the habitat module, housing survival systems, solar arrays, and thermal radiators. Designing this modular puzzle on a computer is straightforward, but actually putting those modular pieces into orbit means mastering several prerequisite technologies down here on Earth first. The first physical prerequisite on ISRO's roadmap is raw power. You need launch vehicles capable of pushing these massive multi-ton modules through the atmosphere. For the initial phases, ISRO will rely on its current heavy-lift workhorse, the LVM-3, previously known as the GSLV Mark III. But modular construction means continuous launches. If the development timeline permits, ISRO plans to fold in a future heavy launch vehicle to handle even larger payloads later in the assembly process. Managing these enormous launches and tracking the modules once they reach orbit also means scaling up ground control operations. Pushing heavy metal into low Earth orbit only solves half the problem. Once the modules are up there, they have to be physically linked together. That brings us to the second, much more complex prerequisite: orbital assembly. To prove this, ISRO is running a test mission called SPADEX. 2 unmanned satellites must locate each other at orbital speeds, align trajectories, and physically dock with zero human intervention. When you are dealing with modules containing a live crew, a slight miscalculation in docking can cause a catastrophic depressurization. Mastering this automated handshake eliminates the margin of error before human lives are on the line. Without successful autonomous docking, those heavy modules are just isolated debris. But once ISRO proves the SPADEX technology, they gain the ability to build an orbital habitat of virtually any scale. This rigorous step-by-step process reflects how ISRO operates as an organization. Rather than attempting to match the scale of other nations, they are designing missions around strict resource efficiency and their own national priorities. That's why the targeted 2030 launch date for this station is built with future expansion in mind. If we look closely at that core module, it is engineered with 6 distinct docking ports. These exist to accommodate future spacecraft and newly designed modules down the road. This 20-ton station will serve as a foundational learning platform. It allows ISRO to gather vital orbital data, test life support limits, and figure out exactly how to keep astronauts safe over long durations. It's a pragmatic, highly deliberate piece of architecture. By securing heavy lift capacity and mastering orbital docking now, India is laying the concrete foundation for an independent future in human space exploration.